Alright, so let's take a look at this normal distribution question, okay? So it says the length x millimeters of a certain species of seashell is normally distributed with mean 25 and variance sigma squared. It says the probability that x is less than 24.15 is 0.1446. Find the probability of x being between 24.15 and 25. Okay, so you really have to make sure you understand the information that's given to you. Okay, so basically what's happening is we have a normal distribution, right? And they're saying the mean is 25, right? So the mean is 25. Now they're saying the probability that x is less than 24.15. Alright, so 24.15 obviously is to the left of 25. So let's just say 24.15 is right here. They're saying this probability is 0.1446. So what they mean is the probability, meaning the area of this normal distribution graph here, if you remember, this represents probability. They're saying this area here, right, is 0.1446. Okay, so they want us to find the probability that x is between 24.15, right, and 25, right? So essentially we're trying to find this part right here, right? So between 24.15 and 25. So if you recall, the mean represents 50%, right? So 50% is 0.5. So all we have to do is take 0.5, because that's 50%, minus this part here, and that will give us this area piece right here that we're looking for. So minus 0.1446. So just calculate that in the calculator, and you would end up with 0.3554. Okay? Alright, so let's take a look at 3b. Okay? So 3b, we need to find the standard deviation. So anytime you need to calculate the standard deviation, it's unknown, or if the mean is unknown, you have to remember that you will be using this z-score formula. Okay? So this formula is in the formula book, so you don't need to memorize it, but just make sure you understand when you need to use this formula. Okay? So anytime the standard deviation or the mean, or sometimes both, is unknown, you'll be using this formula. So using this formula here, so in this situation, remember they told us at 24.15, right? So when the x value is 24.15, right, the area, right, the probability area is 0.1446, right? So here's a picture of the information that we were using earlier. So when we set this up, so remember the z right here represents this area. So we have 0.1446 is equal to, now our x value is our 24.15, minus the mean, which we know, divided by, all right, standard deviation. Now when you're using this formula, what you have to remember is this value, whatever it is, you need to calculate the inverse norm of it, right? So the inverse normal, because that's going to give you the standard deviation, all right, that we need. So let's go to the calculator. So we've got, let me show you how to calculate this. So menu, probability, distributions, and we want to go to inverse normal. Okay, inverse normal. So the area was 0.1446, right? And leave this 0 and 1, right? So leave this 0 and 1. Click OK, and we get this value. So negative 1.059878, right? So this value, after we inverse norm, is negative 1.05, right? 9878. 9878. Oops. 9878. Okay. And then if you multiply by standard deviation on both sides, so this would be standard deviation, is equal to 24.15 minus 25, so that'll leave us with negative 0.85. Now, if you want to find out what standard deviation is, just divide both sides by negative 1.059878 on your calculator, and that will give us the standard deviation. So let me calculate that real quick. So we're going to divide negative 0.85 by this value right here. So negative 1.059878, right? So we end up with 0.802 rounded to 3 significant figures, right? So we get 0.802. So that will be our standard deviation, okay? All right, so part C here now says hence, right? So remember when IB uses the word hence, that's a hint telling you that you should be using something that you calculated previously to help you answer this question, okay? So hence, find the probability that a seashell selected at random has a length greater than 26, okay? So basically, we're trying to find the probability, right, that X, has a length greater than 26, right, is greater than 26, okay? And we have all the information we need now because we know the standard deviation now, and we already knew the mean before, okay? So you just basically just calculate this in the calculator. Let me show you how to do it. So we're going to go to menu, probability, distribution, and we're going to do normal CDF, right? It's a normal distribution, so we do normal CDF since it's an inequality. So our lower bound. Now, since we're calculating X is greater than 26, right? That means that 26 is going to be the smallest value, okay? So we're going to type in 26 because that's our lower bound. That's the smallest value. Now, for upper bound, what you could do is just type in a very large number. So usually what I do is I just type in a bunch of 9s, okay? Now, our mean, we know, is 25, and we calculated the standard deviation now. That was 0.802, right? Go ahead and click OK, right? Now, typically, I like to write all this, right? You should write all this information so that you let the person grading know what you did on the calculator, right? So I would write normal CDF, and I would type in, I would write in all this so that I'm letting the grader know what I did on the calculator. So we have 26, comma 9999, put some dots. The mean was 25. My standard deviation was 0.802. So I make sure I show this so that I can at least earn the method mark, right? Just in case this is worth 2 marks, which it is, right? So then we will get our answer, which is 0.106, right? So 0.106, okay? So it's important that you write this right here because this is your method, right? Just in case you type something wrong in the calculator, if you have just the answer, right, you're not going to get the method mark, okay? So make sure you write this right here because then it lets the grader know what you did on the calculator to try and find this answer. So just in case you make a little mistake typing something on the calculator, you can at least earn 1 mark, okay? All right, so let's take a look at the next part. Okay, so let's take a look at 3D, okay? So a random sample of seashells is collected on a beach. Let capital Y represent the number of seashells with lengths greater than 26 millimeters, okay? So first of all, let's define capital Y. So capital Y represents seashells with lengths greater than 26 millimeters, right? Now, the expectation of Y, so the expectation of capital Y, if you remember the expectation formula, it's just N times P, right? Where N, in this case, represents the 10 seashells, right? So we have 10. And P is the probability of Y happening. So Y is the probability that the seashell is greater than 26 millimeters. If you recall, we calculated this previously, and the probability of a seashell being greater than 26, right? The probability was 0.106, right? So we're going to multiply by 0.106. So 10 times 0.106, that's just going to give us 1.06, Okay, so that'll be the expectation of y. All right, so let's take a look at part E. So part E now says, find the probability that exactly 3 of these seashells, right, have a length greater than 26 millimeters. Okay, so with these normal distribution type questions that are multiple parts, you have to get used to, right, in the middle of these questions, all right, they'll ask a question that all of a sudden becomes a binomial distribution. So when you read this question right here, you have to recognize right away, wait, this is now a binomial distribution question, because if we define this, all right, let's say I define x, all right, is binomially distributed. So there's 10 seashells now, right? And then the probability of it being greater than, or of a seashell being greater than 26 millimeters, we know the probability of that is 0.106, right? So basically this becomes a binomial distribution question, because this question meets our 4 criteria to be a binomial distribution, okay? Now we're trying to calculate what's the probability that exactly 3, so capital X is equal to 3. Okay, so we'll just put this in the calculator. So this is now a binomial distribution question that we're calculating. So distribution, and is it going to be a binomial PDF, because this is an equal, right? And then we have the number of trials. There's 10 seashells. Probability of success. What's the probability of the seashell being greater than 26 millimeters? That was 0.106. And the x value is 3. Okay, so we just type all that in. All right, and then we get our answer. Right, so once again, I would type this right here, binomial PDF. Right, so I would put binomial PDF. I would type in what I put in the calculator. Right, so in this case, we have 10.106 and 3. So 10, comma 0.106, comma 3. And then we get our answer, right, which is 0.0652. 0.0652. Okay? Okay, let's take a look at the last part of this question. Okay? So it says, a seashell selected at random has a length less than 26. Find the probability that its length is between 24.15 and 25. Okay, so this is a really tricky problem, because when you read this, you have to recognize that, oh, this is a conditional probability question. Because of this statement right here, this is our condition, right? So this must happen. So then this now becomes a conditional probability question, right? And we're trying to find the probability that its length is between 24.15 and 25, right? So we're trying to calculate the probability, right, that the length is between 24.15, right, and 25, given, right, that the length has to be, all right, less than 26. So this is our conditional probability, right? So to calculate this, right, it's going to be the intersection of the probability that is between 24.15, right, and 25, intersect with the probability, right, that is less than 26, divided by the probability that x is less than 26. Now let's think about this. So the intersection, this is between 24.15 and 25. So the intersection between 24.15 and x is less than 26, right, is going to just be this. Okay, hopefully that makes sense, right? So if you just think, okay, between 24.15 and 25 is this, right? And then less than 26 is all of this. So the intersection where they overlap is going to just be this part, okay? So basically we have the probability, right? So the probability of 24.15, all right, and 25, all right, on the numerator. divided by the probability x is less than 26. So we calculate this part here. We actually already calculated previously. We know the value to this. This is actually 0.3554. Right? This was from part A in the question. Okay? So if you've forgotten, go back and look at part A. So we already calculated this, or you can always calculate it again. Now the probability of x is less than 26. Now remember, the probability that x is greater than 26, we actually know this. This is 0.106. So the probability that x is less than 26 would just be 1 minus 0.106, right? So 1 minus 0.106. Alright, so 1 minus 0.106, that's 0.894. So we just divide this, and then we will get our answer, which is going to be 0.399.